All right, in this video, we're going to teach you how to find one root of a polynomial. Okay, so just the process to find one root. There are many possible roots to polynomials, and there is a process that we use to find one particular root. That root will then help us to move on and solve that polynomial for all of its roots. Now, these polynomials are not quadratics. They are not difference of two squares. They are not sum of two cubes, difference of two cubes. These are polynomials that are made up of more terms than we're used to looking at, and these are polynomials that we can't use our current strategies to solve. So we can't factor them. We can't apply some sort of a quadratic pattern to them. They don't fit the typical mold, and so we have to go through this process that we're going to teach you to solve them. And it's a long, involved process. We're going to do several different videos. Each part is going to walk you through the process of doing that, okay? So all polynomials that are not otherwise factorable or otherwise quadratics are solved this way. So the first thing we're going to do before we jump into how to find those roots is to just review again real quickly what rational, irrational, imaginary means, because we're going to use those terms a lot from this point on. We're going to have all different kinds of roots from these polynomials. Some will be rational, so meaning they'll be whole numbers, fractions, repeating decimals, terminating decimals. So let's go ahead and write that down. So examples of rational numbers, when we say that, means the roots could be whole numbers. The roots could be a fraction, like 1/2 or 2/3. The roots could be a repeating and or terminating decimal. Okay. Now, we don't usually give our answers in decimal form. We typically will give them in fractional form, whole number form. We almost always never really write them in repeating or terminating form. You won't see that very often. Irrationals are non-repeating and non-terminating decimals. So these are numbers like that are in root form that when we go ahead and put them into our calculator, they don't repeat and they don't seem to have an end. So it makes it really difficult to figure out, where do I put that on a number line? Where would I put that number if I don't really know where its end is and what two other numbers it comes between in the grand scheme of things? So these are non-repeating and also non-terminating kinds of numbers. Okay? And then imaginary, of course, is our imaginary unit I, and that always comes from a negative root. So we have some sort of a negative under a radical, and that's where our imaginary numbers come from. Okay? So just to review again what those terms mean. Now, I'm going to scroll the page up a little bit, and we're going to try to walk through this process. I'm going to have you try to be as patient as possible. Hang in with me. Rational root theorem. Okay. Here we go. Good stuff right here. You can talk about this at the dinner table and be very impressive. Factors of the constant term. So this is how we're going to find all the possible rational roots. We will never use all of those. We're just looking for one. I just need to find one root to get me through this process. So what we do is we take the factors of the constant term. So remember, your constant term is C in your equation. You're going to find that letter, that number C in your equation, and you are going to list all of its factors, and that will be the numerator. And then you're going to list all of the factors of the lead coefficient. Remember, that's your A in your standard form quadratic or polynomial. This isn't a quadratic, this is a polynomial. So you're going to do that first, and you're going to find all the possible rational roots. And you'll notice it says list every possible numerator with every possible denominator. And then number 2 is test each in the equation. Those that are equal to 0 are in fact rational roots of the polynomial. Okay? So we're looking for that rational root. That's our goal. We're going to use the example x cubed plus x squared minus 3x minus 3 as our example. And I'm going to ask you to some of you might already be jumping ahead when you're thinking about these fractions, that there are some repeats. I'm going to ask you to just stay patient for a little bit with me. We're going to talk about that in a second. So factors of the constant term. My constant term in this equation is 3. So all of the factors of 3 are 1 and 3. But here's what you need to know about that. I could have, remember when we listed it this way and we were looking for all the different, we could do +1, -3, we could do +1, +3, we could do -1, +3, or we could do -1, -3. So there's a lot of combinations. So we have to do +or -1 and +or -3. Those are all of the separate factors of 3. Now I'm going to do all the separate factors of my leading coefficient, which again is my A term, and that is 1. So I need +or -1. And this is a fairly short one. You could imagine if the lead coefficient was like, let's say 6, and let's say the constant term at the end was a 12, we would have a multitude of combinations here. Okay, so first we listed our possible factors. Now we have to list every possible numerator with every possible denominator, like this. +1, okay, so now right now I'm concentrating on +1 with both denominators. So +1 could go with a +1, or +1 could be divided by -1. So that takes care of my +1. Now I'm going to do the same thing this time with the -1 with both denominator. Okay? So maybe I should do them in colors, right? So -1 and +1, -1 and -1. And now let's do that with 3. So I'm going to do +3 with both denominators, +3 with +1, +3 with -1. And then I'm going to do it again, but this time I'm going to do it with -3, again with the denominator. So -3 with +1 and -3 with -1. Okay, so +1 divided by a +1 is +1, and +1 divided by -1 is -1. Negative divided by a positive is negative. Negative divided by a negative is a positive. Positive divided by a positive is a positive. Positive divided by a negative is a negative. Negative divided by a positive is a negative, and negative divided by a negative is a positive. Whoops, +3. I didn't write my positive here. So you will notice that regardless of whether it's positive divided by a negative or negative divided by a positive, it's going to still result in -1, right? So we can just write that -1 one time. And then also, when you have a negative divided by a negative and a positive divided by a positive, those are also equal to +1. Both. So the moral of the story is, you can just kind of say positive, if these are both 1s, it's going to result in +1 and -1. So we could kind of use the same theory with the 3 and the 1. Like our only combinations are going to be either it's going to be a +3 or it's going to be a -3. And if you look at what's happening, that in fact is the case. The 2 negatives result in a +3. The 2 positives result in a +3. So I'm going to have +3, and then I'm going to have the 2 negative versions where it's positive divided by a negative or negative divided by a positive, which both result in -3. So really we have 4 possibilities here that we have to test. These are the 4 possible roots. One of those should be where the parabola crosses, or where this particular polynomial crosses the x-axis. Okay? So first we listed our c terms, our factors of c, over our factors of a, and then we literally matched up every single one and calculated what their answer would be. But I'm showing you here that there's a little bit of a shortcut. We don't always have to do this whole process. We can certainly know that if we have a 1 over a 1, it's either going to be a +1 or a -1. There really are no other options for choices. Same thing with 3 over 1. It's either going to be +3 or -3. So we can kind of eliminate a little bit of the work there when we're doing that. And we'll practice a few more in a few minutes. That'll make more sense. So that's step 1. Step 2, test each in the equation. Those that are equal to 0 are in fact rational roots. So I'm going to erase this and scroll the page up, and then we can talk about what we're going to do with +, -1, +, -3. okay? So we're going to test it in the equation, and the easiest way to test in the equation is to use synthetic division, right? There's two ways, but definitely synthetic division is the way to go. So we're going to test positive 1, so this was our positive 1, this was our positive 3, this was our negative 1, and this was our negative 3. We have to test all 4 of them. You go through your list and you test until you find a root, okay? And then you're done. You don't have to test all of them. You just test until you find one that works. And when I say one that works, I mean one that equals 0, where there's a remainder of 0. Because we learned, remember, that when there's a remainder of 0, it means that that is where the polynomial is crossing the x-axis. It has, when x is this number, y is 0. So when we get a result of 0, that means that that is in fact a x-intercept, a root, a 0. And that's why we call them zeros. Okay? So synthetic division, remember we set that up to be 1 in the box. And then remember that the numbers that go along here come from our polynomial. I know you can't see that on my screen right now, but the x to the 3rd term, the x squared, the x, and then the constant term. The coefficient for the x cubed was 1. The coefficient for the x squared term was 1. The coefficient for the x term was a negative 3, and the constant was negative 3. So remember, we're going to test it, and our goal is to get a 0 in here. That's what we want. Okay? We want a remainder of 0. That would mean that it's a root. So drop the first. 1 times 1 is 1. Add them up. 1 plus 1 is 2. 2 times 1 is 2. Negative 3 plus 2 is negative 1. Negative 1 times 1 is negative 1. I get a remainder of negative 4, not a 0. So it's not a root. Next, let's put in 3. 1, 1, negative 3, negative 3. Let's test. Drop down the 1. 1 times 3 is 3. 3 plus 1 is 4. 4 times 3 is 12. 12 minus 3 is 9. 9 times 3 is 27. 27 minus 3 is not 0. So again, not 0, not a root. Let's try negative 1. I'm squishing up my space here. All right, so there are my coefficients. Let's plop this in here. Drop down the 1. 1 times negative 1 is negative 1. Negative 1 plus 1 is 0. 0 times negative 1 is 0. Add them up. Negative 3. Negative 3 times negative 1 is positive 3. Positive 3 and negative 3 is 0. We just found a root. All right, so we are in business. That means we don't even need to bother to test negative 3. All right, we have what we need to move on. That is the process of finding a root, okay? The next video is going to tell you what to do when you have that root and how to continue on, okay? So this is the process of finding the root. You do all of your factors of your constant term, all of your factors of your lead coefficient, figure out what your possibilities are, and test them using synthetic division until you find one that gives you a 0 as a remainder. Remember, that's always that last number that you get. When you find one that's a 0, you have found a root.